Okay, here are some key formulas. Value of financial assets, value of a bond, yield to maturity, yield to call. Okay, we're gonna discount all the cash flows we get because after purchasing the bond to present to get our bond price. Okay, and we're gonna calculate the interest rate of the bond. And we also call the interest rate yield to maturity or yield to call. Okay, so let's first look at the concept of a bond. Bond is a debt security under which the issuer owes the holders a debt, and depending on the terms of the bond, is obliged to pay them interest, the coupon, or to repay the principal at a later date, termed the maturity date. Interest is usually payable at fixed intervals, semi-annual, annual, and sometimes monthly. Okay, so here we know that bond is a debt security. Okay, it's a contract. Okay, and it's a contract certificate showing that the issuer owes the holders a debt. Okay, so if you purchase the bond today, okay, paying the bond price, in the future, according to the contract, you will get you will get interest from the bond issuer. Okay, because you're lending a certain amount of money to the issuer. So in the future, as a payback, you would get interest. Okay, during the bond's maturity time, you will get interest, and we call this interest coupon payments that you're getting. Okay, and this coupon payments is usually ordinary annuity or annuity due. Okay, and then at the maturity date, when the bond matures, you will get a principal, you will get a lump sum at the end of the maturity date. Okay, and for the coupon payments, they occur at fixed intervals. Okay, they're very similar to annuity. So the money you will get in the future after purchasing the bond is very similar to our first type of uneven cash flow. Annuity plus a lump sum in the end. Okay, we have coupon as the annuity we're receiving, and we also have principal as the lump sum we're receiving in the end. Okay, so you are paying a certain bond price today to purchase the bond, which is equivalent to the concept that you are lending such money to the company or you're lending such money to the government. Okay, so in the future, you will get cash inflow. Okay, the company or the government will pay you back in terms of coupon payments as annuity and in terms of principal as lump sum at the end of the maturity date. Okay, so here are some key features of a bond. Par value. It is the face amount of the bond which is paid at maturity. Assume 1,000. Okay, so this is the amount of money that is on the contract stating that at maturity date, you will have to pay this par value. Or as an investor, you will receive this par value, but the issuer, the government, or the corporation would have to pay you this par value. Okay, it's the lump sum that you receive, or the issuer is paying at the end. Okay, and we also have the concept coupon interest rate. It is the stated interest rate paid by the issuer. Okay, it's also on the contract. Okay, and if we use par value multiplied by coupon interest rate, we will get the dollar payment of interest. For example, if we have a bond with 1,000 par value, 10% coupon interest rate, then the coupon payment you will be receiving at fixed intervals will be 1,000 multiplied by 10%, which is 100. Okay, and then we have maturity date. This is the years until the bond must be repaid. If it's a 10-year bond, the maturity date is 10 years. We have issue date, when the bond is issued. Okay, usually we say the issue date is today. Or if you're buying the bond from someone else and it's a 10-year bond and the person has been holding this bond for 5 years, then the issue date would be 5 years ago. Okay, yield to maturity. This is the rate of return earned on a bond held until maturity, also called promised yield. Okay, this is the same thing as what we learned as interest rate in the first two classes, Chapter 7, Class 1, Class 2. Okay, the interest rate of a bond. Okay, in the market, we call it interest rate. But as an investor, this interest rate is our rate of return. Okay, this is also our yield to maturity, okay, because this is our earning before the maturity date or promised yield. Okay, for the bond issuer, such as government or corporation, actually this rate could also be called cost of debt. Okay, from the issuer's perspective, this is their cost, and it is their cost of debt. And from our buyer's perspective, from investors' perspective, this is our rate of return. Okay, this is our return by purchasing the bond. This is our yield to maturity. Okay, let's look at specific examples of the bonds so you can understand better about this concept. And let's use zero coupon bond as our first example here. Okay, zero coupon bond is a debt security that doesn't pay interest but is traded at deep discount. Price is much lower than par value, rendering profit at maturity when the bond is redeemed for its full face value. Okay, so we just mentioned that after you purchase the bond, you're very likely to receive coupon payments before the maturity date and principal or par value at the maturity date. So here, when we are looking at the zero coupon bond, the coupon payments happen to be zero. Okay, so you will only receive the par value at the maturity date. For example, if we have a bond with a face amount of 20,000 maturing in 20 years with a price of 6,757. At the beginning, you spend 6,757 to buy this zero coupon bond, and at the end of the 20 years, the investor will receive 20,000. What is the interest rate of this zero coupon bond? Okay, this is a typical example of zero coupon bond. You are paying 6,757 today, okay, as the bond price. Let's look at this timeline here. Okay, the question gives us the amount of money you're paying today as the bond price. So we use a negative sign here. This is cash outflow for you today. Okay, because it's a zero coupon bond. So in the next 20 years before the maturity date, we have zero coupon payment over the 20 years. Okay, n equals to 20. At the end of the maturity date, okay, or at the end of the 20 years or 20th year, you will receive this par value. Okay, we call it par value. We also call it face amount. We have this principal amount repaid to us as 20,000. Okay, this is a cash inflow for you after 20 years. Okay, and we're asking for R. Okay, we know the present value, we know the future value, there's no annuity here, we know the N, we're solving for interest rate, I/Y, or rate of return. We can also call it yield to maturity or interest rate. Okay, different names for it. So this is actually using time value of money method, and we're just applying it to the case of a bond. And here we're using the case of a zero coupon bond. Okay, but the bond price is actually the present value we've learned before, because this is something we're paying today. And the par value, face value, or the principal we're getting after 20 years is future value we're getting. Okay, and the 20-year, the maturity date is N. Okay, and we don't have annuity, we don't have coupon here. We're looking for I/Y. Okay, you already learned how to do such questions in 5 and 6, class 2, okay? Or even class 1, this is a lump sum question. You know the FV and you know the PV. This is a lump sum question. You are looking for I/Y, okay? You already know how to do this. We're just applying the method we learned in our first 2 classes to the bond chapter. Okay, you will see in the future through our whole course, when we go to the stock chapter, when we estimate corporation project, we will use what we learned in the time value of money chapter throughout our course to different scenarios, to bond scenario, stock scenario, or project estimation scenario. Okay. So here, we just need to use our financial calculator and input our present value as negative 6757, okay, the bond price you are paying today, N as 20, future value as 20,000, payment as 0 because it's 0 coupon bond. And when compute for I/Y, okay, we get 5.5757. Okay, and of course, the number you see on the calculator does not have a percentage sign. So when you're answering the question, the interest rate of the bond should be 5.5757%. Okay, you add the percentage sign back. If the question is asking you what is the yield to maturity of this zero coupon bond or rate of return, it is asking the same thing, or cost of debt for the firm. It's all these are, okay? Another special thing about bond is a call provision. Some bond has it and some bond does not. Call provision allows issuer to refund the bond issue if rates decline. It helps the issuer but hurts the investor. Okay, remember this is the cost of debt for the issuer. So if the market rate decline, they're likely to if there is a call provision, the firm can decide if they want to call back the bond or not, and issue a similar bond with a lower interest rate or lower cost of debt in the market. Okay, so borrowers are willing to pay more, and lenders require more for callable bonds. Okay, so if the firm has the flexibility or option to call back the bond, usually the lenders or you as an investor, you would require higher rate of return for the callable bonds, okay, because the additional right or option that the firm has. The call provision generally states that the issuer must pay the bondholders an amount greater than the par value if they are called. The additional sum, which is termed a call premium, is often equal to 1 year's interest. Call premium declines over time as the bonds approach maturity. Okay, so if the investor is able to hold the bond until maturity date, then you will receive a par value. Okay, as well as some more coupon payments before the maturity date. Okay, so now if the issuer decides to, or if the issuer has the right to call back the bond earlier, usually the bondholder will lose some coupon payments because the bond is being collected before the maturity date. Okay, so the amount of money you receive on the call date is usually larger than the par value you could have received at the maturity date. Okay. The additional sum, which is called a call premium, is often equal to 1 year's interest. Call premium declines over time as the bond matures maturity. Okay, so the call premium, the additional amount you are getting because of the earlier calling back of the bond, will decline as you reach maturity date, okay, because you collect more and more coupon payments as we get closer to the maturity date. So the compensation for you to have this bond called back earlier, the call premium declines. Okay, bonds are often not callable until several years after issue, generally 5 to 10 years. This is known as a deferred call, and such bonds are said to have call protection. Question: true or false? A call provision gives bondholders the right to demand or call for repayment of a bond. Typically, companies call bonds if interest rates rise and do not call them if interest rates decline. This is false. Okay, the companies call bonds if interest rate decline. Okay, usually if the market interest rate declines, then the company could call back the current bond and refinance in the market by using a lower rate. That's why they would like to call back the bond, even though they would have to pay for a higher call price than the par price. Okay, but they would not call back the bond if the interest rate increases. Otherwise, they would have to refinance the money in the market at a higher rate. Okay, we will look at more specific examples of how to price a bond. But now let's look at the general principle we're using here to price a bond. The market value of any real or financial asset, including stocks, bonds, or real estate purchased in hope of selling it at a profit, may be estimated by determining future cash flows, then discounting them back to present. Okay, this is also using what we learned in chapter 5 and 6. Time value of money. Remember, whenever we're solving for present value or the value of a financial asset or real asset, we're basically discounting all the future cash flows we're getting to present to have the current value of the asset. Okay, so in the bond case, if we want to evaluate the bond price, we need to discount all the cash inflows we're going to get in the future, including the coupon payments, okay, from year 1 to year 2 to year N. N is the maturity date. We also need to discount par value, which we will receive at the end of year N. Okay, so and the discount rate, of course, depends on what time you are getting this this cash flow. Okay, so for the coupon at the end of the first year, we divide by 1 plus R, 1 plus interest rate to the power of 1. For the coupon we're receiving at the end of year 2, we discount by 1 plus R to the power of 2. Okay, until the last coupon actually occurs at the same time as par value, so we can add them together and divide by 1 plus interest rate to the power of N. Okay, this gives us bond price. We're just discounting an ordinary annuity here as the coupon payments plus a lump sum as the par value in the end. What is the opportunity cost of debt capital? Okay, again, this discount rate here, this bond interest rate here is called rate of return for the investors. It is also called cost of debt for the bond issuer. Okay, and this is the same thing as what we learned in last 2 videos, interest rate for the bond. Okay, and it can be determined by using R star, real risk-free rate, plus IP, inflation premium, plus MRP, maturity risk premium, plus DRP, default risk premium, plus LP, liquidity premium. Okay, and we can also call this yield to maturity or yield to call that we will be discussing later again. And this is also this interest rate, cost of debts, rate of return is also this discount rate we're using here to discount the future coupon payments and the par value to get the present bond price. Okay, so the discount rate is the opportunity cost of debts. It is the rate that could be earned on alternative investments of equal risk. Okay, it's an opportunity cost. Let's look at another example of evaluating the price of a bond. And this time we're pricing a par bond. Okay, what is the value of a 10-year, 10% annual coupon bond with par value of 1,000 if cost of debt RD is 10%? So in this question, we know that the key information here is that this is a 10-year, 10% annual coupon bond, which means the maturity date N is 10. This is an annual coupon bond, and the coupon rate is 10%. Okay, and the par value is 1,000. The cost of debt is 10%. Okay, the interest rate, the cost of debt, the bond interest rate, the cost of debt, the rate of return from investors' perspective is RD, which is 10%. Okay, we mark this as RD because this is the cost of debt. All right, here by definition, we can first calculate that the coupon payments equals coupon rate, 10% here, multiplied by par value, which is 1,000 here. So we know that the coupon payment for this bond is 100. Okay, so when we are marking the timeline, this question is solving for the value of the bond, VB, or price of the bond at time 0. And before the maturity date after 10 years, we have 100 coupon payments for at the end of each year for 10 years. Okay, as coupon payments. This is an ordinary annuity as coupon payments for 10 years. Each payment is 100. Okay, and we can mark here that this interest rate for the bond is 10%. Okay, besides the 10 100s, we also receive 1,000 as par value at maturity date. Okay, at the end of the 10th year. Okay, so if we want to solve for the value of the bond, we need to discount all the future cash inflows to present, to time 0. That would be bond price. Okay, so we can either do it by formula, by discounting these 10 or 100s one by one. Okay, for the first 100, we divide by 1 plus 10%. For the last 100, we divide by 1 plus 10% to the power of 10. And for the last principal or par value we're receiving at the end of the 10th year, we divide by 1 plus 10% to the power of 10. Okay, and we add all these numbers. We calculate each discounted value, add them up, so we have the total discounted value of all the future cash inflows, and this is worth 1,000. Okay, this is the bond value or bond price at time 0. Okay, an alternative way to solve for this question is to use our financial calculator, because this bond has a 1,000 lump sum or par value due at maturity time when t equals 10. And we have annual 100 coupon payments beginning at t equals 1 and continuing through t equals 10. So the price of the bond can be found by solving the present value of this lump sum, 1,000, and the present value of this ordinary annuity of 100. Okay, so we can input N as 10, I as 10 because the interest rate is 10%, payment is 100 because the coupon payments are $100, future value is the par value as 1,000, and we compute for present value. The calculator would give us the answer negative 1,000. Okay, you can try this with your own financial calculator, or I can show you here on my virtual financial calculator. Okay, so for this question, I would input 10 year as N, 10 interest rate as I, Payment 100, future value 1,000, compute for PV. Okay, so our present value or the bond price here is negative 1,000. This is something you need to pay today to purchase the bond. So in the future, you will have $100 at the end of each year for 10 years. You will also have 1,000 par value after 10 years at the end of the 10th year. Okay, and for this particular bond, we call it par bond because it meets two criteria. First, here, our yield to maturity or cost of debt or interest rate is 10%, okay, given by the question. And our coupon rate here is also 10%. Remember, we use this 10% coupon rate multiplied by par value 1,000 to get the coupon payment 100. Okay, so here our yield to maturity equals coupon rate. So we can say it's a par bond. Another criteria for par bond, which occurs usually at the same time with this first criteria, is that the bond price here is 1,000 as we calculated. The par value is also 1,000. Okay, so any of these two criteria can prove that this is a par bond. And usually these two criteria exist at the same time, okay? Because our yield to maturity equals coupon rate, we would have a bond price equivalent to par value. Another type of bond here is premium bond. For example, we have the same company as the last example of par bond. So we have the same par value, $1,000, and the same cost of debt, 10%. We have a 10-year bond outstanding with the same risk, but we have 13% annual coupon rate this time. Okay, our annual coupon rate for the par bond is 10%. Here for the premium bond, we have a higher annual coupon rate, which is 13%. So if we use this 13% annual coupon rate multiplied by the par value, 1,000, we would have 130. This is the annual coupon payment, 130. Okay, higher than the par bond, 100. Since the risk is the same, the bond has the same yield to maturity as the previous bond, which is 10%. In this case, the bond sells at a premium because our coupon rate exceeds yield to maturity, and the bond price is higher than its par value. Okay, we say this is a premium bond, or this bond sells at a premium because our coupon rate is 13%, higher than the 10% yield to maturity or interest rate. Bond price, we will calculate it later. It should be higher than the par value now. Okay, remember, when coupon rate equals yield to maturity, it's a par bond. Price equals to par value. Now, the coupon rate is higher than yield to maturity, which means we're receiving more coupon payments than the par bond. So when we discount all the coupon payments and the par value, the price is going to be higher than the par value. It's going to be a premium bond. Okay, so if we draw the timeline, we're still solving for VB at time 0, but we have 130 for 10 times until from year 1 to year 10, and we have a last 1,000 at the end of the 10th year. Okay, this is a premium bond, coupon rate higher than yield to maturity, price higher than par. Okay, you could probably pause the video now, and try to work on your own to solve for the bond price. Okay, you can either discount 10 or 130s and also discount 1,000 and add them up to get the bond price. Okay, this is using our formula, or you can use our financial calculator. You can use 130 as ordinary annuity, 1,000 as last lump sum, and you need to input I, N, and compute for our present value. Okay, please pause for a minute. Try to solve this question on your own by using financial calculator and formula. If you finish work on this question, you can continue this video and let's look at the answer. Okay, the answer is shown in this graph here. We can input our N as 10, I as 10, okay, because it's given that our yield to maturity, discount rates, cost of debt, interest rate of return for the investors is 10%, okay, because this premium bond has the same risk as par bond, so we have the same interest rate, 10%. However, our coupon rate increased from 10% to 13%. So our coupon payment here we're going to input is 130, which is 13% multiplied by 1,000. Okay, so payment 130. Future value is the par value, 1,000. Compute for PV. We're going to get negative 1184.34. This is the bond price. It is higher than the future value, the par value, because this is a premium bond. So we have a price higher than par value. We have a yield to maturity, coupon rate 13%, also higher than interest rate 10%. Okay, let me show you on the financial calculator. If I input 10 as N, 10 as I, but this time the payment is 130, payment 1,000 as future value, compute for PV is gonna be higher than the par value, where we will have to pay 1184.337. Okay, so we've discussed about par bonds and premium bond. Let's discuss the third type of bond, discount bond. Okay, this time we still have a 10-year bond for the same firm. The bond has the same risk, same yield to maturity, 10%. However, we have a lower coupon rate compared to the par bond. Okay, now we have only 7% as our annual coupon rate. So our coupon payment becomes 70, which is 7% multiplied by 1,000. So we only have 70. Okay, same risk, same yield to maturity, our interest rate is still 10%. But we say this bond sells at a discount because the coupon rate is less than the yield to maturity. The bond price will be lower than its par value. Okay, this is a discount bond, or we say the bond sells at a discount because our coupon rate is only 7% this time, lower than the 10% yield to maturity. Also, our bond price is only $70, less than, our bond price is something that we will calculate later. It's gonna be lower than the par value, 1,000. Okay, so we will input N as 10 years. Or before we look at the answer, please pause the video again, okay, to try to solve for this question on your own. We know it's a 10-year bond with 10% yield to maturity, 10% annual coupon rate, $70 annual coupon payments. Okay, please, and the par value is 1,000. Please calculate the bond price. Okay, you can pause the video if you're still working on the question, but you can resume the video and proceed with me to look at the answers. Okay, so the answer is shown in this graph here. We can input N as 10, I as 10, payment as 70, future value as 1,000. Okay, and compute for present value. So we have negative 815.66. Okay, let me do it on the calculator here. 10 as N, 10 as I, payment now this time is lower, 70. Okay, lower payment or coupon payments compared to par bond or premium bond. Okay, 1,000 future value. Compute for PV. Okay, we have the lower price compared to par value. We only have 815.66 as our price, lower than the par value. Okay. Change in bond value over time. What would happen to the value of these three bonds if the required rate of return remained at 10%? So for par bond, our price continues to be 1,000. Our coupon rate is 10%. Our yield to maturity is also 10%. And at maturity date, the bond value is also 1,000 because we get 1,000 par value. For the premium bond, the starting price is 1184, and the value of the bond declines as more and more coupon payments are paid out. At the end of the maturity date, the premium bond with 13% coupon rate is worth 1,000 because we just have 1,000 par value. For the discount bond, the price is lower than the par value, 816, because the coupon rate 7% is lower than the yield to maturity, 10%. And the value of the bond actually increases, okay, as time goes by. And at the maturity date, the bond value increases to 1,000, which is the same as par bond. At maturity, the value of any bond must equal its par value. If cost of debt remains constant at 10%, the value of a premium bond would decrease over time until it reached 1,000. The value of a discount bond would increase over time until it reached 1,000. The value of a par bond stays at 1,000. Okay, practice. What if we have a company that has a bond maturing in 8 years with a par value of 1,000, making an annual coupon interest payment of 65? The market requires an interest rate of 8.2% on these bonds. What is the bond price? Okay, so we know the N as 8, par value, which is the future value, as 1,000, coupon payment 65 as payment, interest rate as 8.2. We're looking for PV, the bond price. Okay, please pause this video. Try to work on this question on your own by using the financial calculator and formula. And think about what type of bond is this bond? Is it par bond, premium bond, or discount bond? Okay, so if you have finished the question, let's come to look at the answer. If you haven't finished the question, please keep pausing the video. Otherwise, let us look at the answer here. Okay, so this is the timeline we could draw for this question. We're looking for a value of the bond at time 0. We have 65 for 8 years and also 1,000 at the end of the 8th year. The interest rate is 8.2%. Okay, so here we can just input N as 8 years, I as 8.2, payment as 65, future value as the par value 1,000. Okay, and we have this 65 because it's given by the question here. And we compute for present value, we have bond price as 903.0443. Okay, and we say this is a discount bond because the price is lower than the par value and because the coupon rate here is lower than the interest rate 8.2. How do we calculate coupon rate? We just use the coupon payment 65 divided by par value 1,000. So we have 6.5% as our coupon rate. It is lower than our yield to maturity or interest rate 8.2%. Okay, so this is calculating bond price when we know other information about the bond, such as maturity date, interest rate, coupon payments, and par value. What if we know the bond price, but we're looking for I, yield to maturity here? Okay, Yield to maturity is the rate of return earned on a bond if it's held to maturity. It is considered a long-term bond yield, but is expressed as an annual rate. Another comparable concept is yield to call. This is the rate of return earned on a bond when it is called before its maturity date on the call date. Question: coupon payments stay fixed. How could we estimate our expected return on the bond purchase? If the bond is not callable, we will remember the call provision we talked about. The bond issuer has the right to decide whether they call back the bond or not. If the market interest rate is very low, the firm could probably call back the bond and refinance at a lower rate. Otherwise, they will not call back the bond. Okay, if the bond is not callable, we know that the investors will hold the bond until the maturity date for sure. So our rate of return would be yield to maturity. But if there's a call provision and that the market rates declined and that the firm decided to call back the bond, then we will only hold the bond until the call date. So the rate of return is called yield to call. Okay, and here is an example and we will look at examples where we solve for yield to maturity or yield to call for bonds. For example, solving for yield to maturity for this discount bond. What is the yield to maturity on the 10-year 9% annual coupon, 1,000 par value bond selling for 887? Okay, we try to solve for R. We know if we discount all the coupon payments and also the final par value using this yield to maturity or interest rate or cost of debt or RD, we would get the value of the bond as 887. Okay, so we first calculate coupon payments. If we use this coupon rate 9% multiplied by the par value 1,000, we would have $90 as our coupon payment. And we will have this $90 for 10 years. So we discount 10 90s. For the last 1,000, we also discount by using 1 plus RD to the power of 10. Okay. And again, for this RD we're solving for, we're calling it yield to maturity here. It's a little bit hard to solve for yield to maturity using the formula. So it's better to do it with our financial calculator because yield to maturity or yield to call is just the interest rate or I/Y on the calculator. The bond price is just the present value on the calculator. The coupon payment is payments or ordinary annuity on the financial calculator. The par value is the future value. Okay? You can pause the video again and try this question yourself. But if you have finished the question, let's look at the answer here. Okay, for this question, we can input N as 10 because this bond is 10-year. Present value as the given bond price, but remember, the bond price is something you are paying for today. So we input negative 887 as our PV. Our payment here is the 9% coupon rate multiplied by par value, 1,000. So we have 90 input as our payment. Future value is the par value, 1,000. The interest rate, yield to maturity, is something we compute for. So we have 10.91. So the yield to maturity for this bond is 10.91%. This bond sells at a discount because coupon rate here is 9%, but our yield to maturity is 10.91%. The coupon rate is lower than yield to maturity. Also because the bond price 887 is lower than the par value 1,000. The next question asks for yield to maturity for a premium bond. This bond is a 10-year bond, 9% annual coupon, 1,000 par value, selling for 1134.2. Okay, you could pause the video, look at the question only, and try to solve this question on your own. If you have finished, let's look at the answer. Okay, for N, we input as 10 because this is a 10-year bond. For PV, we input our bond price because this is something, bond price is something we're paying today. So we input negative 1134.2. Payment is something we receive in the future as coupon payments. So we use 9% coupon rates, annual coupon rate multiplied by 1,000 par value. So we have 90 coupon payments for 10 years. Okay, we input positive 90 because that's something we're going to receive for 10 years. Future value, positive 1,000. We're going to receive this 1,000 at the end of the 10th year. Compute for I, we're going to get 7.08. We add back the percentage sign, and this should be yield to maturity for this premium bond. This is a premium bond because the coupon rate, 9%, is higher than the yield to maturity, 7.08%. Also because our present value or bond price, 1134.2, is higher than our par value, 1,000. So we say it's a premium bond. Okay, our, I think, last question in this video or in chapter 7, class 3, okay, is about solving for yield to maturity and yield to call. Okay, now we have a bond which has a call provision. Okay, it has an annual coupon interest payment of 7.35%, par value 1,000, current bond price 1130. It matures in 12 years. But according to the call provision, this bond can be called back in 5 years at 1100. Okay, and we call this price call price. Okay, this is the price you would get at the call date if the firm calls back the bond. So you could either hold the bond for 10 years and get, 12 years and get this par value 1,000. Alternatively, you could hold the bond for 5 years and get the call price 1100. Okay, but the firm or the issuer, the Radoski Corporation, is gonna decide whether they want to call back or not. What is the yield to maturity on these bonds? What is their yield to call if the bonds are called by the firm in the 5th year? Okay, so let's solve for yield to maturity and yield to call. You could pause the video again and try to solve for them yourself first. If you finished working on this question on your own, let's look at the solutions here. First, let's solve for yield to maturity. Okay, we input N as our maturity date, 12. We input price as our current bond price, negative 1130. Negative because this is something we're paying today. Payments, we should input the coupon payments. So we use the coupon rate, 7.35% multiplied by the par value, 1,000. So input 73.5. Future value, par value, 1,000. Compute for I, we have yield to maturity as 5.82. And we add back percentage sign as the interest rate. If we're looking for yield to call instead, now we have the same coupon payments, but only for 5 years. Okay, and we discount call price instead of par value for the 5th year. Okay, we have the same bond price, but we discount 5 coupon payments and the last call price. So we input N as 5, the call date, present value still as bond price, negative 1130, coupon payment still 73.5. Future value, we input as 1100, the call price instead of the par price, and we compute for I. So we have yield to maturity as 6.03%. Okay, add back the percentage sign, so that's yield to call. So the 2 different inputs we do here for yield to maturity and yield to call is N and FV. For N, if we're looking for yield to maturity, we input maturity date. If we're looking for yield to call, we input call date. For future value, if we're looking for yield to maturity, input par value. If we're looking for yield to call, we input call price. Okay, and for both cases, we input present value as bond price and payment as coupon payment. So these two inputs are the same for the two cases. All right, so that's all about solving for bond price PV, solving for yield to maturity and yield to call.